squirrels, welcome to the Squirrel Game Dev. In today's short we are going to fix the frame issues. Previously we managed to create and render them. It was really interesting, so unless you watch it, go to the card in the top right corner and make it up. Before the stream started I changed the number of frames to 60. It's almost totally smooth animation, but the character takes it even worse than before. As you can see, the main bottleneck is the way we show these frames. We just change them one by one depending on the direction we swing trim. The only thing which decides about the speed of the frame replacement is this modulo to line where we divide modulo the frame offset, and when it's even, we change the frame. That's an unflexible rubbish. We subtract the one frame no matter if we move trim by 1 pixel or 1000 pixels in one offset chunk. That is my second idea. I just subtract an offset from the middle frame, and that's how I calculate the next frames. I got some restrictions too, so we couldn't get over the frame number limit. It's more flexible because it takes care of the shifts value, but as you can see, these numbers are too big, so it gets to the top frame too quickly. The key is we shouldn't subtract an offset from the middle frame. Something more scalable can be more useful. But what? I found a pretty good way to get around the physical formulas. Fortunately we don't need them here. The regular average from the last few offsets should be enough. Look at this board I made. The buffer works quite simply. We push values inside, and when it overflows it pulls out the last value. We just push our offsets inside and calculate the average from these ones still existing in the buffer. It's gonna also get rid of the halting problem. If we push zeros when there is no motion, next frames will get closer to the middle frame. The more places in the buffer, the slower frames change, so we need to keep that in mind. Here's the buffer implementation. I called it stuck on purpose. You were so confused about it that you subscribed to my channel and liked my video. The max value it takes in the constructor specifies the number of places in the buffer. Its default value is 10, but by trial and error I found 12 to be the most acceptable value to test it. And already you can see it works. It's so smooth. Wow, but what's the problem? Maybe you realize we need to swing so strongly to make it float to the maximal position, so to the last frame. But watch what will happen when I open it full screen or just widescreen. I drag it and there is no problem. When the offset is bigger, there is no problem because the average is higher. Anyway, it shouldn't depend on the screen size. We should somehow convert our offset in pixels to the unit involving screen width. The best way I found is to use the buffer again. Let's say that 10 pixels is equal to 1% of the screen width. We apply a buffer there. If the total number of pixels we store inside gives 10, then we move our character about 1% of the screen size. Simple. We can divide that situation into 3 cases. The first 2 are easy. However, in the third one, we've got an overflow. We need to check how many times the number we want to place inside runs through this buffer and what's the final buffer's value. The calculate buffer function I made does these 2 things. And you can see the trim dances when we drag him. That's great. You can see that when I leave the mouse, the trim doesn't fall either, but we can repair it. I just forgot to change the previous variable for pixels to the buffer overflow counter. Let's say if it works. You can see it works, but trim goes out of the screen. To check whether the head is not going out of the screen, we need to just check if the offset we want to add to the player's exposition isn't more than the game itself. If it is, we add zeros to the buffer. If not, we calculate the buffer size by adding next offsets inside. It works pretty well, don't you think? In the next stream we're going to take a look at the falling subscriptions from the sky. Bye!